Okay, notes today on solving inequalities. Page numbers at the top, page 42 or 56. Find your place there. And we will get started. And we're going to fill up this whole page. I will be pausing, so don't worry if you feel like I'm going fast. So we're going to start with an inequality here. 3x plus negative x plus 5 is greater than negative 2x plus 9. Now for this first one, I'm going to draw the algebra tiles so we can see that connection between what you saw with the tiles last week, and then we're going to write the steps out. So over here on the side, I'm going to draw a box to put my algebra tiles in. Right, the expression mat, so that's dot, 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 dot down the middle with that question mark in between, which side is greater, and we're going to draw in what we have. So we have 3 x's, those are our long ones. And remember, if they are positive, like those are, we shade them in, right? The shaded ones are positive and the clear ones are negative. So there's 3x, and we have a negative x, so we're going to draw that one. That's clear. And we have 5 units, so 1, 2, 3, 4, 5. Those are positive, so again, I shade them in. Okay, on the other side of the mat, I have 2 negative x's. So I'm going to draw those. 1, 2. Again, the clear means they are negative. And then I have 9 units. So I'm going to group those up and draw 5 and then 4. So I know that there are 9. And again, those are positive. So I'm going to shade them in. Okay, so there is my inequality equation on the expression mat. And so now we're going to start with our steps. First thing we would do is look for any 0 pairs that we have, which we got, right? We have a 0 pair right here, positive, negative. So we're going to circle that one and say I can get rid of that, draw a line through it, because 0 means I don't have to worry about it. So that one's gone. Okay, as I look on both sides of the mat, there's no more 0 pairs, right? Left side, they're all positive. Right side, I have positives and negatives, but not of the same kind of tile. So remember, my goal for solving an equation is to get all the x's on one side of the mat. So as I look at this, I would like those 2 negative x's to go away. Well, we can add tiles to create 0 pairs, which is what I'm going to do. Now, those 2 tiles are negatives, so I'm going to add 2 positive x's, right here. I'm shading them in because they're positive. But if I add 2 positive x's to that side, I have to do the same thing to both sides. That's considered a legal move. So add 2 x's to each side, right? That keeps it balanced. And now I did create 0 pair, 0 pair, and those are gone. Okay. Oh, I'm gonna take a step back here, and we're gonna write these in as we do them over on this side. So my first thing that I did when I made that first 0 pair, that was really that subtraction step. 3x minus x is 2x, right? And plus 5 is greater than negative 2x plus 9. Then I added those 2 x's to both sides. I added 2x to the right side and 2x to the left side. Well, 2x and 2x is 4x plus 5 is greater than, now negative 2x plus 2x, that's 0. So that's gone. I circled it there, and now I just have 9 left there. Okay, so that's where I am. Whoops, that's, oh, I got a step ahead of you. All right, that's fine. It is 9. So now we've got all the x's on one side, but I want to make the units go on the other side. So I want these 5 units to go away. Now I can take them away as long as I take them off of both sides. So if I take 5 here, I have to take 5 here, right? Which is fine, as there are 5 on that side to take. So I'm going to subtract 5 from the left side and subtract 5 from the right side. And I get 4x is less than 9 subtract 5 is 4. So there I am on my last step. I've got 4x on the left and 4 on the right. Well, if I have 4x and 4, I can give every unit to an x and end up with x is greater than 1. And there's my solution. How about that? Now, if we were actually dragging the tiles, we could show that matchup, but can't drag them on here. All right, so I'm going to write my steps down. What exactly did I do right there? Okay, my first step was to combine like terms. Right? That's what I did when I said 3x minus x, which was making that 0 pair. Second step is I created 0 pairs. And that's when I added those positive x tiles to each side so that I could create 0 pairs. They weren't there, but I made them happen. And so really what that is adding or subtracting. Step 3, okay, I multiplied or divided, which is how I got from 4x is greater than 4 to just x is greater than 1. So our last step is to multiply or divide. There are our steps. Now we're going to add something else underneath of that. So we're going to sort of leave that open there. But that's what we did with the tiles to get to where we needed to go. Now we're going to do a couple more problems and we'll see how those steps work out. So our next problem is 6x minus 8 is less than 4. Now, we're not going to draw another model for this one, right? We don't have that much space, but we're going to just show the steps. So there's no combining like terms. When I look at this on each side, there's nothing that I could add or subtract. So trying to get that x, this, by itself, really, that's my goal. So first thing I want to do, combine like terms that didn't happen, create some 0 pairs, which is adding and subtracting. I can add 8 here. So that means I have to add 8 to the other side. Got to always do the same thing to both sides because that made 0 pairs right there. So now I have 6x is less than 4 plus 8 is 12, right? So that was my second step. My third step is multiplying or dividing. To get that x by itself, right, I need that 6 to go away. It's 6 times x. So the opposite is dividing, again, always both sides, to make that 6 go away. 6 divided by 6 is 1. That leaves x by itself. And 12 divided by 6 is 2. And that's my solution. X is less than 2. Done. Okay, another example. Now that one should seem a little more familiar. You've worked with two-step equations. Two-step inequalities really work the same way. All right, let's look at another one that might be like, whoa, what's going on here? This one is x divided by 4 plus 7 is greater than -3. So there's our problem. Let's write some steps. Now, combining like terms? No. x over 4 plus 7. We can't add that. So my first step is step 2, which is making some zero pairs. I want that plus 7 to go away, so I subtract, right? 7 positives, 7 negatives makes 0. 0. But if I do that on one side, I have to do it on the other. So I'm going to subtract 7 there. And I end up with x over 4 is greater than negative 3 minus 7. That's a boom, boom, which means it's negative 3 plus negative 7, negative 10. If you're struggling with that, grab a calculator because we want to make sure we have the right number there. Okay, so not finished yet. We have to get rid of the 4 because we need x by itself, right? Our goal here is that we have x is greater than something. How do we figure that out? Well, this is division, right? X divided by 4. The opposite of dividing is to multiply. And when I do that, the 4 cancels out. So on the other side, same thing, always remember on both sides, multiply by 4. Negative 10 times 4 is negative 40. And there's our solution. X is less than negative 40. Okay, so one more example. I know you're like, wow, these are hard. They're notes, right? That's why we're writing them down, and then we're going to do a lot of practicing on this. Okay, so the last problem, it's a bit tricky. The actual problem isn't, but it has a weird thing in it. So it's negative 4x plus 5 is less than or equal to 13. Okay, so starting with our steps, combining like terms, no. 4x plus 5 those aren't like terms. Second step, making zeros. Yeah, we're going to add or subtract. I want to turn that plus 5 into 0, so that means I have put 5 negatives up there, right? Those are all 0 pairs. But I have to do the same thing on both sides of the equation, which is the same as both sides of the mat. So subtracting 5 on that side. So now I have negative 4x less than or equal to 13 subtract 5 is 8. Okay, all looking good. Like we did on the second example with the 6x, to get rid of that 6, we divided. Well, I'm going to divide again, but this time it's negative 4. Make sure that negative sticks with the number. This is negative 4 also. Okay, well, that's 1. There's x. 8 divided by negative 4 is negative 2. That's all good. This is where the weird thing happens. Okay, because we divided right here by a negative, that means that our inequality right there flips. So it goes to, instead of less than equal to, it goes to greater than equal to, because we divided using a negative. So our answer on this one is x greater than or equal to negative 2. This is what we needed to add here. That's why I didn't close that little box up there. So we need to say on that step 3, when we multiply or divide, when you multiply, I'm going to abbreviate with the symbols, or divide using negative, flip the inequality. That means the symbol, right? So when you have to use a negative, not when you subtract, but if you divide or multiply with a negative number, flip the inequality. That's the only time it happens. So don't get excited and do that all the time.